Okay, let us look at this work example. You are given two events A and B, and the probabilities of A given B and B given A are given to you. Okay, so the first part of the question says to check whether A and B are independent, and you need to justify your answer. Okay, so what we can do is we can use our conditional probability to help us. So we need to check whether the probability of A given B, whether is it the same as the probability of A. If they are the same, means that these two are, the events A and B are independent. However, if they are not the same, which is in this situation, then the two events will not be independent. Okay, so you need to state the values of the probability of A given B and say that it's not equals to the value of the probability of A. Okay, before you state that the two events A and B are not independent. Okay, for the second part, determine if A and B are mutually exclusive. So for mutually exclusive, we remember that I need the probability of A intersect B to be equals to 0 because the intersection set is an empty set. Okay, so we can use our conditional probability to find the value of the probability of A intersect B or B intersect A. They are the same. Okay, so you just have to sub in the values accordingly for the probability of B given A and the probability of A. Then you can find the probability of the intersect. And clearly this is not equals to 0, so therefore A and B are not mutually exclusive. Okay, now lastly, we need to find the probability of B. So how are we going to do that? We are going to use our conditional probability again. Okay, so we're going to use the formula for the probability of A given B, which is to have the probability of A intersect B in the numerator and the probability of B in the denominator. Okay, then we plug in our values. So as you can see, the probability of A given B is half, right? Okay, so we can plug that in. So on the left hand side, you will get half. Okay, then on my right hand side, the A intersect B, this set is the same as B intersect A. Okay, these two sets are the same. So I can write A intersect B as B intersect A, and then from previously in part 2, we found the value of B intersect A, right? So I can plug that in as well. Okay, so my equation will become half equals to 1/6 divided by the probability of B, and then from there you can find the probability of B.